Last section, 6.7, let's get started. We're trying to identify the difference between a geometric sequence and an arithmetic sequence. So really the question is, are we adding to get to the next entry in the sequence, or are we multiplying to get to the next entry in the sequence? Arithmetic has always been adding, and now geometric means we're multiplying to get from one term or one entry to another. Are we adding or are we multiplying? If we're not doing either, then it's not arithmetic and it's not geometric. So let's take a look at this. To go from 120 to 60, I can either add a negative 60, or I can multiply by 1/2. Okay? So we now have to look at the next term. The next term is 30. So to go from 60 to 30, I either add negative 30 or I multiply by 1/2. And now I have at least a pattern, and I can check it on the third one. In other words, it doesn't make sense to be subtracting a different number each time, because then I'm going to have to guess the number. The next number to go from 30 to 15 is I'm going to have to add a negative 15. These numbers keep changing, but I'm looking for something to be constant or consistent. And if I look here, that means to go from 30 to 15, I have to multiply by 1/2. So since I'm constantly multiplying by the same number, 1/2, this is going to be a geometric sequence because there is a common ratio between each entry term. We'll put term to be official. Term. Oh, sequential. That's the word I wanted there. So there's a common ratio between each sequential. In other words, I went in the same order it showed. I didn't jump around. Sequential, and that is important because our ratio would change if we went from 60 to 15. We wouldn't multiply by 1/2. We would multiply by 1/4, and all of a sudden it would look like our ratio changed, when in reality it didn't, because 30 is in between. We are constantly multiplying by 1/2. That's what sequential means and why it's important. This is, I don't know what this blank is for. I think I wrote an extra one, not thinking. But it is an arithmetic. Or sorry, no, it's a geometric. Wow. I saw blue and automatically went to that. It is a geometric sequence. All right. Now let's look over here, because normally we'd have an example where it's like, oh, that one is geometric, the next one must be arithmetic. And I'm going to tell you, it's not. It's actually going to be neither. So we're going to look at this and go from 2 to 6 means we need to multiply by 3. To go from 6 to 11, I can't multiply by 3. I'm going to have to end up multiplying by less than 2, so 1 point something. So the pattern automatically breaks. Okay, so if I go from 2 to 6 and add 4, can I do the same thing from 6 to 11? Remember, I'm not jumping around just to make something work. I'm looking and going in the same order the pattern occurred in. So we're going to have to add 5. Now, because I have no pattern of adding, because I have no pattern of multiplying, because there is not a common ratio nor common, oh my gosh, why did my brain turn off? It's the adding thing. Formal terminology is leaving my brain. Let me look it up real quick. I've got it right here. See, it wasn't even in here in the book because I had this and now it's gone. different. There is no common difference between each consecutive or sequential term. This is not a geometric nor arithmetic sequence. So again, what we're looking for is, are we adding the same number between each term? It can be positive or negative, doesn't matter. And that's how we find our difference. Or are we multiplying between each sequential term by the same number? And that means we can multiply by a fraction or a non-fraction, positive or negative. If neither one of those is true, in other words, if the number changes that we're adding or multiplying, then it's neither arithmetic or geometric. It's geometric if we're multiplying by the same common factor. In short, if we multiply by the same number between each sequential term. And if we're adding the same number between each sequential term, then it is an arithmetic sequence.